Hello and welcome. In this video we are going to look at energy changes in reactions, and we are going to look at endothermic and exothermic reactions. Now on the left hand side over here I've got an example of an exothermic reaction, and an exothermic reaction is one that transfers energy to the surroundings, transfers heat energy to the surroundings. One example is neutralization, and that's the reaction between an acid and an alkali. So if I reacted an acid and alkali together, I would get an exothermic reaction, and this would give off heat to the surroundings. In addition, if I was to use a temperature sensor and measure the temperature over a period of time, you would see the temperature rise slowly as the reaction proceeds. Now on the other side of things, we have what's called an endothermic reaction, and this takes in heat energy from the surroundings, and therefore energy goes into the reaction. And if we were to put a temperature sensor here, you would notice that the temperature would actually go down because it's drawing in heat energy from the surroundings. Now just one point to mention here, if this is a reaction that doesn't take much heat energy to get going, you could actually hold on to it and you would feel the tube here get much cooler in your hand because it would draw away heat energy from your hand. Something like thermal decomposition, and you may remember the thermal decomposition of maybe calcium carbonate from chemistry unit 1. This requires a lot of heat energy, so you wouldn't actually be able to hold that in your hand and feel it get colder. You'd have to supply it with a lot of energy in order for that reaction to proceed. But there are lots of reactions that you could just carry out at room temperature, and when you hold on or stick a temperature sensor in or a thermometer in, you can see the temperature go down. So don't get confused between the idea that thermal decomposition takes quite a lot of heat energy, but lots of reactions can actually happen around about room temperature and cool down, and you can actually detect that quite easily. The next thing I want to look at is this idea of a endothermic reaction and exothermic reaction happening with just one set of reactants and products, and that's one where the reaction is reversible. So over here I've got a substance called hydrated copper sulfate, and this can be used to show a exothermic reaction and an endothermic reaction. And the way we do that is to show the endothermic reaction, we can apply heat to this, and what happens is after a while it turns into a substance called anhydrous copper sulfate, and this reaction can be shown like this. We've got hydrated copper sulfate, it converts to anhydrous copper sulfate plus some water. So in this reaction the water will just evaporate off, and it's a chemical reaction producing these two products, and it's an endothermic reaction. So in the forward direction, by the way, this symbol means that it's reversible. In the forward direction, this reaction is endothermic. So that means we have to supply heat energy to it, and it will draw in energy from the surroundings. However, if we were to let this cool down and then add some water, what you would find is the opposite direction, the opposite reaction going in the opposite direction. The anhydrous copper sulfate reacts with the water and creates or produces hydrated copper sulfate. Now this is an exothermic reaction, and that means that it will give off heat to the surroundings. In actual fact, if you were to put a thermometer in there, or if you were actually to hold it, you would feel that it would get very warm because it was giving out energy to the surroundings. So this is an example of a endothermic and exothermic reaction happening in a reversible reaction. Okay, so this is one that you might have seen in class, or certainly one that you should be familiar with for this topic. The last thing I really wanted to go through was just a couple of applications of this idea of endothermic and exothermic reactions. First one here is an example of a hand warmer, and with a hand warmer, and with this hand warmer you can either use chemicals that carry out reversible reactions or non-reversible. If they're non-reversible, this would be something like calcium oxide and water that would be unmixed inside there. You'd have a bag perhaps inside that could be broken, would cause the water and the calcium oxide to mix, and therefore create an exothermic reaction which would warm up. This would be non-reversible, and that means this would actually be disposable. On the other side of things, you could have a reversible reaction, so there are various chemicals you could add in there that could create a reversible reaction, and that means this would be reusable. And you should be able to compare these two types of hand warmer and give advantages and disadvantages of both of those. So disposable ones generally tend to stay warm for longer, where the reversible ones tend to be reusable, but they don't stay warm for as long amount of time, and therefore has a slight disadvantage there. Another example we have is a cold pack, so you could have two chemicals in there, for example ammonium nitrate and water, and this has a cooling effect, and this can be used to treat sports injuries and things like that. Okay, so that's an overview of endothermic and exothermic reactions. Hope that was useful. Thanks for watching, and see you again soon.